Hey everyone, in today's session, we are going to learn what is sorting and one of the sorting technique that is bubble sort. Uh, First of all, we'll understand what sorting is. So, if we have set of elements with us, we may want them to be sorted in any specific way. For example, if we have a set of numbers, we may want them to be arranged either in ascending order or a descending order. So if we have a collection of, or if we have a set of names with us, we may want them to be arranged alphabetically. So to perform this sorting, there are multiple sorting techniques. Today we are going to learn bubble sort. In bubble sort, we are going to compare each element with the next element in the list. So if these two elements are not in the correct order, then we are going to swap them. I mean, we are going to exchange them. Okay. So for example, we are going to compare first element with the second one. Then second element will be compared with the third one, third with the fourth one. So this we are going to repeat this process until all the elements are compared. So we will see this with an example directly. So this is the example where we have five elements with us. Okay, where we are going to compare each element with the next element. For example, if we have these elements, then we are going to compare element 40 with its next element 50. Okay, so we are trying to arrange these elements in ascending order. So smaller element should come first. So if we compare 40 with 50, 40 is smaller than 50. So they are in a correct order. We are not going to exchange them. Then we are going to compare the second element with the third element. So if we see here, 30 is smaller than 50. So 30 should be appearing before this 50. We are going to exchange them. So 30 came here and 50 came here. Then we are going to compare third element with the fourth element. So 20 is smaller than 50. We are going to exchange them. So 50 came here. Then we are going to compare fourth element with the fifth element. So 10 is smaller than 50. We are going to exchange them. So if you see, like at the end of this stage, like the biggest element, the largest element is placed at its proper position. That is at the last position. Okay. So we call this as pass one. So in pass one, okay, if we have five elements with us, we are going to perform four comparisons. Okay, first element is compared with the second one is compared with the third one, third element is compared with the fourth one, and fourth element is compared with the fifth one. Okay, and at the end of this pass, the largest element will be placed at its proper position, that is at the last position. Okay, so whatever output we have at the end of this pass one, so the same output will be input to pass two. So again, in pass two, we are going to follow the same procedure. First element will be compared with the second element. Okay, second element is smaller than the first one. We are going to exchange them. Then second element will be compared with the third element. So 20 is smaller than 40. We are going to exchange them. Then third element is compared with the fourth element. So 10 is smaller than 40. So we are going to exchange them. Now we are not going to compare this fourth element with the fifth one, because 50 is already placed at its proper position. So we are not going to do this comparison. So in pass 2, we will have only 3 comparisons done. First element with the second one with the third one, third element with the fourth one. So this last comparison will not be done. Okay. And if you see at the end of this stage, the second largest element is placed at its proper position. Okay. So whatever output we have here, so this will be input to the next pass. So the next pass is third pass. Okay. So in the third pass, again, we are going to follow the same procedure. We are going to compare first element with the second one. If they are not in order, we are going to swap them. So second element will be compared with the third one. If they are not in order, we are going to swap them. So in pass 3, there will be only 2 comparisons, because after 2 comparisons, the third largest element is placed at its proper position. Okay, so next comparisons are not needed. So the output of pass 3 will be input to this pass 4. Okay, so here we are going to perform only one comparison. So 10 is smaller than 20. We have exchanged them. After this comparison, if you see, fourth largest element is placed at its proper position. Okay, as well as like only one element will be left. So this is also placed at its proper position. Okay, so like if we have 4 elements, like if we have 5 elements with us, okay, if we have 5 elements with us, if we have 5 elements with us, then number of passes will be 4. Okay, if we have n number of elements with us, then the number of passes will be n minus 1. Okay, uh, so just to understand the logic behind this bubble sort, I'm just going to clear out this screen and we'll consider this example in detail to understand the logic. So now it's very clear to all of us that if we have n number of elements, then we will have n minus 1 number of passes. Okay. So in our example, we have 5 elements with us. In that case, the number of passes will be 4. And it's very clear to all of us that we are going to compare every element with its next element. For example, so if I have the element A of I, then I am going to compare this element with A of I plus 1. Okay, every element will be compared with its next element. Okay, so let us understand what is this I. Okay, we are going to use like 3 variables in our logic. First of all, n, this is number of elements. N is number of elements. Passes, we are going to use the variable j here for representing the number of passes. And the comparison, the number of comparisons that we are going to do. So for the number of comparisons, I'm going to use the variable I here. Okay. So initially, like we have 5 elements. So n is equal to 5. So we are in pass 1. So the variable j will be is equal to 1. Okay, we are in pass 1. And in pass 1, we are going to make 4 comparisons. So this is First comparison, second comparison, third one, and fourth one. So here, I am going to perform 4 comparisons. Okay, for the number of comparisons, we are going to make use of the variable I. Okay, so initially, we are going to initialize this I to 0. Okay, so if I is equal to 0, in that case, I am going to compare I of 0 with I of 1. I told you, like A of I will be compared with A of I plus 1. When I is equal to 0, I'm going to compare A of 0 with A of 1. So this is my first comparison. Okay, A of 0 is compared with A of 1. Okay, so if they are out of order, we are going to exchange them. Then we are going to increment this I by 1. So now I will come here. Okay, yes, so the value of I has become 1 now. We are going to compare I of 1 with I of 2. A of I plus 1. So A of 1 will be compared with A of 2. Okay, if they are out of order, we are going to exchange them. Then I am going to increment this I by 1 again. So now I will be 2. I am going to compare A of 2, A of 2 with A of 3. This is my third comparison. Okay, so this is my third comparison. So now, yes, if they're out of order, we are going to exchange them. I am going to increment this I again by 1. Now I's value is 3. I am going to compare A of 3 with A of 4. Okay, A of 3 with A of 4. Right? So, if you see the value of I, we started with 0. The initial value of I should be 0 and the last value of I should be 3. In that case, we are performing 4 comparisons here. Okay, so the range of this I, it should be from 0 to 3. It should be from 0 to 3. Okay, it should be from 0 to 3. Now, let us try to write a formula for this. Okay, let's try to write a logic for this. Okay, we have 5 elements. We are in pass 1. How many comparisons we should have? We should have 4 comparisons. In that case, the value of I should be from 0 to 3. Okay, we're just trying to generalize this logic. Okay, we're trying to generalize this logic. The value of this I should be from 0 to 3. Okay, so initial value is 0. Okay, how to find this last value of this I? It totally depends on the number of elements we have and in which pass we are. Okay, and in which pass, in which pass we are, right? So the number of elements that we have is, the elements that we have is 5. Okay, we are in pass, we are in pass 1. Okay, to this we are going to add 1. Okay, to this we are going to add 1. Okay, so I'm just trying to write that here. We are going to start from 0. Okay, the last value will be the number of elements that we have minus in which pass we are plus 1. Okay, in which pass we are plus 1. Okay, so if we apply this to pass 1, see the number of elements we have is 5. We are in pass 1. So plus 1, if you evaluate this, 5 minus 1 plus 1, it's 2. So 5 minus 2 is, so this will be evaluated to 3. Okay, the range of this I will be from 0 to 3. in that case, we will have 4 number of comparisons. Okay, let us try to understand this with the next pass. Okay, so let me take this as a of 0, a of 1, a of 2, a of 3, and this is a of 4. Okay, this is a of 4. Right? Now, we are in pass 2. Again, let me write it here. N is equal to, number of elements is 5. We are in pass 2. So, J is equal to 2. So, what should be the range of I? What should be the range of I in second pass? Okay. Again, we are going to start comparing first element with the second one. So, let me initialize that variable I again to 0. Okay, my initial value of this I is again 0, right? So if it is 0, if I is equal to 0, I'm going to compare it with I plus 1. So first comparison will be done. Yeah, then I am going to increment the value of I by 1. Now the value of I is 1. It will be compared with I plus 1, that is A of 2. Okay, that is A of 2. Second comparison will be done. Then I is incremented by 1 again. I will be 2. In that case, it will be compared with the next element, A of 3. Okay. So now if you see, only 3 comparisons must be done. 1, 2, 3. So in this case, what should be the range of I? It should be from 0 to 2. It should be from 0 to 2. Okay. How can I get this range? Let's apply this logic again. Okay, I is equal to 0 to the number of elements that we have. Okay, it's already written here. The number of elements that we have is 5 minus, in which pass we are? We are in pass 2. Okay, plus 1. So this will be 5 minus 3. 5 minus 3 is nothing but 2. Okay. So it will be, I will be from 0 to 2. So 3 comparisons will be done. 0, 1 and 2. Okay. Now we are going to take these elements to the next pass. That is pass number 3. So that's pass number 3. Pass number 3. Okay. Now, number of elements we have is 5. Okay. Number of elements we have is 5. Okay. We are in pass. We are in pass 3. J is equal to 3. Now, the value of I, the range of this I will be again starting from 0. Okay, let me take this I is equal to 0. Okay, so in that case, A of 0 will be compared with A of 1. Then I should be incremented by 1. I will be 1. A of I will be compared with, A of 1 will be compared with A of 2. So we only need 2 comparisons in this case. Right? We only need 2 comparisons in this case. The value of I will be from 0 to 1. Right? How can we find this from the logic? Yes. So how can we find this from the logic? So the initial value of I is 0. Okay. The number of elements we have is 5. We are in pass 3 plus 1. So 5 minus 3 plus 1. 5 minus 4. So this is nothing but 1. So only 2 comparisons will be done. 0 and 1. Okay. Now if we come to pass 4. Okay. If we come to pass 4. So this is A of 0. A of 1. So A of 2. A of 3, A of 4. Okay, right? So if we see like this case, if we see this case, again, like we have n is equal to 5. We are in pass 4, so j is 4. I, okay, what should be the range of I? How many comparisons must be done here? Only one, right? So I is equal to 0. I is equal to 0 to 0, because if I is equal to 0, it will be compared with like A of 0 will be compared with A of 1. So one comparison is done. So the value of I should be only 0. Okay. How can we find it with the logic? Yes, number of elements we have is 5. We are in fourth pass, plus 1. So 5 minus 4 plus 1. So 5 minus 5 is nothing but 0. Only one comparison will be done here. Okay, only one comparison will be done in this case. So let us see this logic with the program. So the logic that we have seen till now, we are going to put that into a code. Okay. So yeah, so this is the main function where we are reading the total number of elements first. Okay, in our example, so this is 5. Okay, we are going to read n number of elements into this array, right? Now we have a logic. Now we have a logic here for the bubble sort. Okay. Now, like in bubble sort, we have number of passes. Okay, we have number of passes, and in each pass we have uh, uh, like a particular number of comparisons. Okay, so we should have two loops for this. Okay, so the outer loop, if you see the outer loop, okay, this is for the number of passes, right? In each pass, we are going to have a particular number of comparisons, right? Comparisons. Okay, so the outer loop must always be for a pass, and inner loop will always be for comparisons, right? So, as like we have discussed, if we have n number of elements, okay, if we have n number of elements, we will have n minus 1 number of passes, right? We will have n minus 1 number of passes. The number of passes will be from, like this j will be from 1, 2, 3, so up to n minus 1, right? So in our case, so j is equal to 1, 2, 3, 4 because n is equal to 5, right? So if you look at the conditions in this for loop, initial value of this j is 1 because we are going to start from pass 1, and the last pass must be n minus 1. So j is less than n. It is nothing but j is equal to n minus 1. Okay. So it will be n minus 1, right? J is less than or equal to n minus 1, right? We are going to increment this pass every time. So in each pass, I told you the number of comparisons will be from I is equal to 0 uh, to n minus j plus 1. N minus j plus 1, right? Okay. So if we are in the first pass, okay, if we have 5 elements, if we are in the first pass, right, if n is equal to 5. If we are in the first pass, 4 comparisons will be done inside. Okay. If we are in the second pass, three comparisons will be done. If we are in the third pass, like two comparisons will be done. If we are in the fourth pass, only one comparison will be done. Right? Right? So we have two loops for this. Okay? And if we want, like if the elements are not in correct order, for example, if a of I, if it is greater than a of I plus 1, right? First element is greater than the second element, then we need to swap them. We need to exchange them. We are going to exchange them using a temporary variable. Okay? Values that we have in a of I and a of I plus 1, we are going to swap them using a temporary variable if they are out of order. Right? At the end of this program, we are going to display the elements that are in sorted order. Okay. Now we are going to use the same logic and we will run this program and we'll see the output. Yeah. So, so the same program we have in this online editor here, which we are going to run. Okay, so if you see, we are going to read the number of elements first. Then we are going to enter the elements. Okay, let me run this. We are going to read the number of elements. Let me give 5 elements. We are going to enter 5 elements now. 5, 4, 3, 2, 1. So if you see, we are going to uh, get the elements in ascending order. Okay, because we have we have written a logic where we want to arrange the elements in ascending order. So we can also write a program where we can arrange these elements in descending order just by changing this. Okay. Yeah. So if first element is smaller than the second one, then we are going to swap them. Okay. The elements will be arranged in descending order just by changing this operator here. Okay. So this is about bubble sort. Thank you.